Hi everyone, my name is Paolo De Tori. I am a maintainer with the KubeStellar project, which is a CNCF project focused on application management of multi-cluster. In this video, I'm going to talk about running AI ML workflows on KubeFlow pipelines using KubeStellar. KubeFlow pipelines is a platform for deploying, managing, and scaling machine learning workflows on Kubernetes. Typically, machine learning workflows are run on a single Kubernetes cluster in KubeFlow. However, I'm going to talk about the use case where you want to run these KubeFlow pipelines on multiple clusters. The motivations are the following. First of all, you may want to burst to additional clusters because you may not have enough resources on the local cluster where you are running your pipelines. For example, you may not have enough GPU resources. Second, you may have constraints on data locality. Maybe there is some data that is only available on your local cluster. You may be running on-prem, and then you have some confidentiality of the data, and the data shouldn't be available on the cloud. Maybe you are doing some data pre-processing, filtering the data, anonymizing the data. Then the data could be potentially shared on public cloud. And there I may have additional capacity, running additional clusters to run my AI/ML pipelines. So these are typically scenarios we see as a hybrid and multi-cloud scenarios where workflows can be distributed across between on-prem, cloud, and potentially different type of clouds, because again of availability of GPU resources. And we can also have situations where the GPU resources are heterogeneous. Maybe a cluster provides TPU, another one provides NVIDIA, another one provides other type of accelerators. The goals of the project I'm going to discuss here is really to enable seamless multi-cluster dispatching and execution of KubeFlow pipelines across different clusters. And the basic idea is that a user should be able to just use the existing tools for KubeFlow pipelines. So tools such as the KubeFlow pipeline CLI, the user interface, the API should just work as they are. And especially important, a user should be able to just run unmodified KubeFlow pipeline code without basically any change. The basic idea is that I may start from an existing cluster as a user where I'm running already my pipelines. For example, I'm running an instance of KubeFlow pipelines v2, and then just add KubeStellar. And KubeStellar enable the multi-cluster aspect in KubeFlow pipeline, allow me to now execute pipelines and distribute pipelines in other clusters where I also have installed KFP in a completely seamless way for the user. This is also made possible by adding the ability to manually select cluster where a user may want to run. So this is what we call manual selection. Or this could be based on resource constraints and utilization. For example, I can have enough intelligence in the multi-cluster scheduling portion of my solution to see that a cluster is underutilized, even if all clusters have the same type of accelerator, and then pipelines can be automatically delivered there for execution. Let's now talk about KubeStellar. KubeStellar is a CNCF sandbox project that simplifies the deployment and configuration of applications across multiple Kubernetes clusters. The idea is to provide a seamless experience similar to the same one that you get when you use a single cluster. The user can just define what we call binding policies to essentially connect workloads on the control plane cluster to clusters where he wants to deploy that particular workload. For more information, just go to kubestellar.io. And now let's talk about what happens when we put together KubeFlow pipelines and KubeStellar. all of a sudden we enable the ability to run from a single cluster to multi-cluster. In this architecture, and this is pretty much what I'm going to show in a demo soon, you can see that I have a top cluster, that is the control plane cluster, where I've installed KubeFlow pipelines, and KubeStellar. KubeStellar allows the delivery of workflows from the top cluster to the execution clusters on the bottom. To make this possible, we have configured the bottom cluster to access the same shared S3 artifacts for artifacts and logs, and also for the metadata database that is used by KFP. We've also added a few other components. There is a mutating webhook that will set the workflow in suspend state. And so later on, the multi-cluster scheduler can make decision whether to run that workflow locally on KFP, on the top cluster, on the control plane cluster, or deliver that workflow downstream for execution on the KFP execution cluster. Also, we have another component shown there that is the shadow pod controller that essentially creates pods that reflects the log that are created by the pods downstream. Let's now show a demo. Here is the UI for KubeFlow pipeline version 2.2.0. We can run any of the existing examples that are provided with KubeFlow pipelines. In this example, in this demo, I'm going to show one of the pipelines that are predefined. That is a very simple example of a workflow for data preprocessing that is producing a couple of data sets, and then there is a training step, and finally this results in the creation of a model. Let's create a run out of this. I just have to choose an experiment, and then I'm gonna start this run. And while this is starting, I'm gonna go and take a look to this screen here, where I'm showing on the top screen, I'm showing pods that are being created on the top cluster, what we call the control plane cluster. On the right bottom screen, we are showing pods creating on the cluster number 2. In this particular demo, I have essentially 3 clusters, the one on the top and 2 clusters for execution. And as we can see, pods are being created by the workflow that is being distributed to the bottom cluster number 2. At the same time, we see also what we call the shadow pods that are providing the logging. They are reflecting essentially the logs from the pods that are running in the cluster downstream. And we can go to the UI, and we can see the tasks are actually progressing. We can see all the details of the tasks, the input and output artifacts, the details for the task. We can see the logs, and logs are actually streamed out of the shadow pods. We can see even some information about the cluster where this is executing. And we can even see that if we, for example, open this task, I added some printing to the existing example to show that we can actually show streaming logs. If actually I refresh the UI, I go back, I should see that the count has progressed. And at the end, when the tasks are completed, the logs are retrieved from the S3 artifact store, where the logs are archived at the end of the execution. And those shadow pods will just go away. Let's run another pipeline at the same time with that, and let's see what happened in terms of selection of clusters. Because I'm already using one of the clusters, most likely the scheduler is gonna pick another cluster for execution. And if we go to our terminal here, I will see that now I have another task, another pod running on cluster number 1. And the pipeline is starting. Also, the shadow pods are starting to show up here. And now if I go back to my runs, I can see that I have a new run here running. And the information for this one is also available here. You can see all the data being passed back and forth. Okay, so that was all I wanted to show. And you can see how easy it is to use this model. From the point of view of the user, it looks like exactly running KubeFlow on a single cluster, but now I'm able to distribute my workflow across different clusters in a completely seamless way. Thank you for watching this video. And if you want to learn more about KubeStellar, remember, go to KubeStellar.io. Thank you.